In this session, we're going to be focused on the analysis of variance, often referred to more simply as ANOVA. ANOVA builds on the idea of the independent samples t-test, where we're comparing mean responses for two different groups of participants, let's say for example men and women, for some given metric variable, such as the number of cups of coffee consumed in a day. So independent samples t-test is great when you have two groups. But what happens when you have more than two groups, if you have three or more groups? That's where ANOVA comes in. So similar to an independent samples t-test, we have dependent variable that's measurable, either interval or ratio scaled, and the independent variable is categorical, meaning that we have groups of participants. We can do what's referred to as a one-way ANOVA or an n-way or multiple ANOVA. This simply refers to how many predictors we have. And we're going to focus on a one-way ANOVA first, which means simply that we have one independent variable. Now don't get confused, because you could have multiple groups. So the variable might be, for example, something like the student's majors. And so there's one variable, but you could have four different groups. You could have marketing majors, accounting, finance, and so forth. Now, with the ANOVA, the statistical test that we're going to use is a little bit different, but the interpretation is going to be pretty much the same as what we saw before with the t-test. But in this case, we're going to be looking at the f-test. The intuition behind it is the same, though. We're looking at the ratio of the difference between groups, so the difference between the different means of the groups, and we're looking at that over the variance within the groups. So it's the difference between groups over the variance within the groups. The higher the F statistic, the better our statistical significance. So let's go ahead and look at an example. So using our rent data, I'd be interested to find out what the difference is in rent paid as a function of type of housing. So we're going to go under Analyze, Compare Means, and this time we're going to go all the way down to one-way ANOVA. So our dependent variable in this case is rent, and the independent variable, or referred to as factor here, is type of housing. Now there are a couple options I'm going to pick. I'd like to get some descriptive statistics, and I'm also going to look for a means plot, and you'll see in a second what that is and why it's helpful. So go ahead and click OK. And the first thing we're going to do is inspect the data visually. So we can skip past these tables, and let's just focus on this graph of the means plot. So what we're seeing here is the mean value for rent for each of the different types of housing. So just looking at this, it looks as though there is a difference. But where specifically is there a difference? It looks like houses cost the same, or cost the most in terms of rent, more so than any of the others. But we need to be specific, and in fact we want to know specifically whether there's a difference between house and condo, or between house and other, and so forth. So most likely there's going to be a difference when the means are furthest apart. So it looks like a good candidate would be the rent for house versus the rent for other, or the rent for house versus the rent for dorm. So let's go up and look at our descriptives. Under means here we have the exact same data for mean value for each. Note, however, here the n. This is the number of participants that live in each of these different types of housing. Going back to our means plot, even though it appears that there's a very big difference between house and other, it's going to be challenging to show that statistically because there's so few people that actually selected the other option. Same with condo, that is a very small group. And it's going to turn out that the statistical significance depends on a couple of things. The difference in means, remember that's our numerator in the F ratio, but also the sum of our variance. and that's the standard deviation, or related to the standard deviation. And the standard deviation. So the first thing that we want to do, and the only thing really we can do with the current analysis, is determine whether overall there is a difference somewhere within the set of possible pairwise differences. So are any of these different from one another? And the F-test is going to answer that for us. And here's our table right here, the ANOVA table. Here's our between group variance, and that's a good thing, and within groups, that's our noise. So this is our signal, and that's our noise. The ratio of those two leads to an F of 3.052, and that is statistically significant at p less than 0.05. So that's a good first step. It suggests that there is a difference somewhere within the set of means, but we don't know exactly where. To find out, we need to run what's called a post hoc test. So ANOVA doesn't tell us where the significant difference lies, it just says there is a difference. And the test I'm going to focus on is the Chaffee. So I'm going to rerun the analysis with the same options that we had before, but this time I'm also going to ask for a post hoc test, Chaffee. Continue, OK. So we're going to get the same output that we did before with the addition of this table right here. And what you're seeing right here is the set of all the possible pairwise comparisons. So think of this as a set of independent samples t-test. So we could look at the rent for dorm versus apartment, the rent for dorm versus house versus condo versus other, etc. Likewise, you could look at house versus dorm versus apartment and so forth. So there's some redundancy here, but this is showing us all the possible pairwise comparisons. So focusing on the difference between house and other, we saw before that that was quite large. In fact, $1,300. However, that is not statistically significant. And the challenge was that even though we had a big mean difference, we had such a small sample size, and that led to a large standard error. In any case, the thing you want to focus on is the statistical significance. In this case, it's not significant. What we can do next is scan through and see if any of these values are significant. And there actually is one pair that appears to be marginally significant, and that's the difference between dorm and house. The mean difference was $880, and that is marginally significant. So we could conclude that based on this, it's likely that there is something within the set of pairwise comparisons that's statistically significant, and the one that we found that was, at least marginally significant in this case, was dorm versus house.